Okay. Suprabhatam, everyone. Namaste to Guru Priya Chaitanya ji. Looks like you're traveling ji. Thank you for the session today. Welcome. We'll get started now. Om Sahana Vavatu Sahanau Bhunaktu Sahaviryam Karavavahai Tejasvinavadhitamastu ma Vitpushavahai. Om Shanti Shanti Shanti. Hari Om. Astu Mahodaya, we can get started.
Namaste ji. I just need a minute more. Just a second, please.
Okay.
Namaste again. Thank you for allowing me.
No problem.
It's been a lot of joy discussing Bharati Ganita everywhere. I thought we'll have the last class as something very unique to the Indian tradition. A couple of things that would stand out and has a lot of pedagogical merit as well. When we look at Terence Tao, one among the Fields medalists, he encourages in his masterclass and various other sessions, he quite a bit encourages children to learn magic squares. Ideally, we do not know when was the magic square's origin and where it is. There are quite a bit of different claims as to where magic squares originated from. However, we see even with Sri Ramanujam's notes, the first chapter is dedicated to magic squares. And why I want to also do this is because my PhD, a significant portion of it in the math, I research in math, I research in astronomy as well. In math, I've devoted a significant portion of my time to magic squares and unveiling and understanding some among the algorithms in it. When I look at some among the Indian texts, I feel that this has been a very, very unique contribution. And there are multifold understandings about this domain. Let us go into understanding this. A magic square is a simple arrangement of a n cross n grid, right? And in this n cross n grid, now in this example, we have taken a 3 cross 3 grid. Now you can add any of the rows. You will get 23 plus 2 is 25. 25 plus 17, you will get it as
42.
8 plus 14 is again 22. 22 plus 20, you will again get 42. Similarly, all the three rows, right? So 11 plus 26 is 37, plus 5 is 42. Similarly, every column this way, if you add 23 plus 8 plus 11, 23 plus 8 is 31, 31 plus 11 will be again 42. Similarly, 2 plus 14 plus 26, 26 plus 14 is 40 plus 2, 42. Similarly, 17 plus 20 is 37 plus 5 is 42. So all the rows and all the columns add to the same sum, and that is called the magic sum. Similarly, if you see this diagonal, if you try and add this diagonal, 23 plus 14 plus 5, 23 plus 14, again 37, 37 plus 5, 42. Similarly, that was the primary diagonal. This is the secondary diagonal. If you add this two, you will get 11 plus 14, 25, 25 plus 17, 42. So this is called a magic square. This kind of an arrangement was something, it had multiple values in the Indian tradition. So the rows, columns, and diagonals all add to 21. And this such an arrangement of a square is called a magic square, with 42 as the magic sum. So let us try to look at the numbers that has been used to fill these magic squares. And if we put them in an ascending order, we get 2, then 5, 8, right? So we get 2, 5, 8, 11, 14, 17, 20, 23, and 26. These are the 9 numbers that have been used to fill this 3 cross 3 grid. We can see that this number is in an arithmetic series. This is in an arithmetic series. You see, they're all there. There is an A and a D. An arithmetic series is defined by 2 parameters, right? The starting unit measure, which is A, and then the common difference D. So the same D will be maintained here in this arithmetic series. And we can see that in the Indian tradition, they considered magic squares and construction of magic squares based on such arithmetic series. One may ask, will only arithmetic series work? So there are constructions of magic squares without arithmetic series. However, if you want to prescribe an algorithm to construct a convincing mathematical combination of the magic square, which is consistently delivering algorithm, then you would need an arithmetic series to do this. Very, very interesting. This they had figured out in the Indian tradition. Today with brute force, we can try to figure out various number combinations that would allow us to do this. But the Indian approaches have been very intelligent. And you will see that they largely utilize arithmetic series. Arithmetic series is called Shredhi Ganita. Shreni means a ladder. So Shredhi Ganitam means that which is like an arithmetic series. And if you look at a staircase or a ladder, it starts at a particular level and then there is a uniform climb, right? In a well-constructed ladder that or a stair, that is. So it starts at A and it keeps jumping D units every other step that we take. So that's why this is called Shredhi Ganita in the Indian context. We can also see that if we sum total the arithmetic series that we have used and divided by what is called as the order of the magic square. In a 3 cross 3 magic square, the order is said to be 3. In a 5 cross 5, it will be 5, 6 cross 6, 6, and so on. Here, if you sum total this arithmetic series, right, and then divide it by the order, you will get that magic sum. Because it is these, if you sum total all elements, right, it is the entire total. We know that this, the sum here in all these 3 are equal. Thereby, if you sum total the entire arithmetic series and divide it by the order, you know that all these have to be equal. So divided by the order, you will get it equally split into as much as the number in the order. So all these were well clearly enunciated. We'll see the verses. The domain of magic square, that is Bhadra Ganita in the Indian context, like many other knowledge systems, dates back all the way to Paramashiva. In the Indian tradition, it is held that the subject of magic squares was first taught by Bhagavan Shiva to Manibhadra, an enthusiastic Bhutagana. Also, the Sanskrit term Bhadra, it means wealth or auspiciousness. It was believed that magic squares brought a lot of good benefits. This even now in many northern traditions, in Jaina traditions. In the southern traditions, we see yantras made of aksharas. You will see a lot of, even now in temples and so on, there are excellent aksharas based on in Tamil. In, if you go to temple carvings, right, you will see different aksharas actually carved into grid formations. I can even try and show you a few. See, if you go to the Khajuraho temple, the Parshvanatha temple, you will see this 4x4 magic square. This in Chennai, in Madambakam, there's the Dhenupurishwarar temple, where here you see the Tamil alphabets, used to form a magic square. These are all well proven Tamil letters. This is called a Shukra Yantra, in fact. This carving goes back to at least 10th century CE. This magic square we'll learn how to construct today. So this, it is said that a very interesting legend is that there was a Bhutagana named Manibhadra. He was one among the Bhutaganas, and he seemed to have been a very enthusiastic Bhutagana. And it is believed that Bhagavan Shiva taught this to first Manibhadra, the domain called Bhadraganita, which is connected to the arithmetic sequence. It is also presented in a beautiful verse. अथ भुवनत्रय गुरुनोपदिष्टमीशेण मणिभद्राय. Can also split it, the sandhi here. अथ भुवनत्रय गुरुना उपदिष्टमीशेण मणिभद्राय कौतुकिने भूताय श्रेढी संबंधि सद्गणितम् सद्गणित चमत्कृतये यंत्रविदां प्रीतये कुगणकाणां गर्वक्षिप्त्यै वक्ष्ये तत्सारं भद्रगणिताख्यम्. He says. So very, very interesting, beautiful verse. So Narayana Pandita is another important Indian mathematician who must be brought to the fore. That is one among I have taken up as a task upon myself, that Narayana Pandita's work called Ganita Kaumudi must become very well popular. That is one among the solemn vows that I myself have taken. Like Bhaskaracharya and Aryabhatta are quite popular, Narayana Pandita is another genius. In his Brihat work called Ganita Kaumudi, which is almost 3.5 times bigger than Leelavati, the last chapter, the 14th chapter, is dedicated to magic squares. It begins with an invocation. Atha. Now, Atha is a Mangala Vachaka Shabda. Many sutras begin with Atha. How does anyone know any sutras beginning with Atha here?
Atha Patanjali Yoga
Sutrani, right? So Atha Patanjala Yoga Sutrani Yogena Chittasya Padena Vacham Malam Sharirasya Cha Vaidyakena. So this Atha is, starts in the Patanjala Yoga Sutram, that is Patanjali's Yoga Sutras. Then Jaiminiya Sutras also begin with Atha. So many Indian ancient subjects begin with Atha. Atha is and now, so to speak, might be the best, sort of translation for Atha. And now, when would we say, having discussed something else, then we'll begin with and now, right? So there is some prior knowledge, which is expected out of Atha. There is some purva samskaras are needed when we begin with the Mangala Vachaka Shabda Atha. So now he is going to start. What is he going to start? He's saying he is going to give some beautiful mathematics. Sad Ganitam, he is going to say. Okay. What is he going to say? Atha Bhuvanatraya Guruna. The 3 Bhuvanas Guru, which is Isha. Upadishtam Ishena. Guruna Ishena. Both are in the Tritiya Vibhakti. So, by the Guru, Isha, of the 3 universes. Guruna Upadishtam, that was taught by him. To whom? For Manibhadraya. Kautukine, Kautukin, Manibhadra becomes Kautukine Bhutaya. Kautukine Bhutaya Manibhadraya. All these are adjectives to Manibhadra. Kautukin means one who is very enthusiastic, like all of you today morning on a Saturday morning there. Kautukin is one with a kutuhala. So Kautukin, such a bhuta is Manibhadra. To him, what was taught? Upadishtam. What was taught? Shredi Sambandhi Sadganitam. The beautiful math called Bhadraganita, he's going to say, Bhadraganitakyam is going to say, that is going to be supplied here. Called Bhadraganita, which was taught by Isha, the guru of all three worlds, to the enthusiastic Bhutagana Manibhadraya, is going to be stated by me. He's going to say, Tatsaram Vakshye. He's going to say. What is he going to say? First, he has said that he is going to present the domain of mathematics that is connected with Shredi Sambandhi, with arithmetic series. And it was taught by the guru of the three worlds, Isha, to Manibhadra, the enthusiastic Bhutakana. Why is he going to teach that? There, he is here telling us the reason as to why he wants to teach this to everyone. Sadganita Chamatkritaye. So, for the delight of the good mathematicians, Sadganita Chamatkritaye. Yantra Vidam Pritaye. Those who are fond of making yantras. This is useful for whom? People who derive joy out of learning, good mathematicians who derive joy out of math. Then, second, he's talking about yantra vidam pritiye. Those who love carving yantras and presenting yantras. Kuganakanam garvakshiptyai. In order to thwart, just a moment, please. So, Kuganakanam garvakshiptyai. For the inferior mathematicians, for their garva to be thwarted. Vakshye tatsaram bhadraganitakyam. See, it used to be very popular in earlier traditions too, in the fora, to challenge mathematical problems to those who come to the court and ask for research funding, right, so to speak. Today also, right, if you want to go do research funding, you've got to pitch to many people, you've got to raise the funds for something. Earlier, who would grant you? The king would grant you. You could be a scholar under the benefit of the exchequer of the king. From the exchequer of the king, if you have to receive grants, you've got to go and prove yourself in the sabha that I'm a good mathematician, for me to teach, for me to research, allow me to provide some provision so that I can go run my Gurukula and take care of myself, take care of my personal needs. One-time grant. Right? To be allowed, you've got to go and then compete in the sabha or present in the sabha and show your prowess. There, if you want to challenge someone very well, there somebody who is not a great Ganaka, he is coming and challenging you in the court. Ku Ganakanam. Su Ganaka is there, now Ku Ganaka is there, inferior mathematicians. Ku Ganakanam Garvakshiptyai. In order to thwart the Ahankara or the Garva of someone, a mathematician who is not so great, presumptuous mathematician. You will see even such a Kon Bhaskaracharya taking at some point in time. Vakshe Tatsaram Bhadraganitakyam. You say very, very interesting. One of the interesting motivations, and Mangalacharna to begin a domain of knowledge. The earliest occurrence of magic squares when it comes to India is found in a word called Kakshaphuta. Why Kakshaphuta means the squares on the shell of a tortoise. It is by the celebrated alchemist and philosopher Nagarjuna of the Jaina Sampradaya. So, in fact, one particular magic square is called Nagarjuniyam in itself. So, the word Kakshaphuta denotes the square patterns, as I said, in the tortoise cells. And Varahamihira, we already saw some, in incredible Varahamihira is one, phrase that used in Brihat Samhita. We saw this in our Bhuta Sankhya class. We saw how the number of civil days in a Mahayuga, he has given it in a Bhuta Sankhya based metrical composition. Now you see here, Varahamihira did an encyclopedia like work called Brihat Samhita. And there he presents this 4x4 grid with repeating numbers. Okay. But if you count these numbers, 2 plus 4, 7, 7 plus 4, 11, 11 plus 7, 18. You will get 18 everywhere. But the beauty of it is, even in broken diagonals. So this, is a leading diagonal. If you consider this is a broken diagonal, something must come here, right? There is 1, 2, 3, 4, fourth cell here that will go down here. It will wrap and come around here. This fourth cell. So that's why it's highlighted in orange. Similarly, 5, 3, it should have come here. If you wrap around, it will come here, and it is called a broken diagonal. Similarly, 2, and then it should have come here. That will come below here, 6, 7, 3. If you count even the broken diagonal, it will still give you 18, very interestingly. Such a arrangement is called a pan-diagonal magic square. However, this this magic square has a repetition of numbers, but he created this for a very, very interesting reason. This is called the Sarvato Bhadra. Okay, he gives a few lines in this chapter, and he gives all this magic, this magic square, especially with Bhuta Sankhya. He says this is the magic square pattern for you to create fragrances, he says. So if you have, for instance, if you have 16 different fragrant elements, okay, like our masala dabba, which is circular sometimes or square grids. Imagine 16 fragrant elements put in a grid like this in these proportions. The same common units, let's say grams, for some reason, 2 grams, 3 grams, 5 grams, 2 grams agaru, taru, patra. He will write some 16 elements, fragrant elements, he will say. Now to create different flavors, these days, to create different flavors and fragrances, all that they do sometimes just change the color of the bottle. But otherwise, here is saying you can create many formats of fragrances based on these combinations. He's saying pick any, if there was agaru, taru, patra, taruko, ushra, all these things here are put in a 4x4 grid. If you pick any 4 elements, you will get the same sum total of 18 grams, and you will be able to create a fragrance like this, right? You can choose any of the row, any of the column, any of the row, any of the diagonals, any of the broken diagonals. Right? You can create, in fact, 54 different combinations of fragrances out of this kind of a magic square arrangement. This is called the Sarvato Bhadra. The different 16 ingredients, he says, looks like the potpourri, right? You imagine, putting all 16 ingredients, taking them in a particular proportion. Similarly, we see in the Jaina, I already showed you, right? In the temple, in the Khajuraho Jaina inscriptions, we see this 4x4, again a pan-diagonal magic square. Again, the uniqueness of this magic square is it's pan-diagonal as in even broken diagonals. And any 2x2 section actually will lead up to the same magic sum. Then there is the Tijaya Pahutta Stotram in the Jaina tradition. We find another 4x4 magic square which leads to the magic sum of 170. Okay. This, when you look at this particular arrangement, it leads to a magic sum of 32. Similarly, if you look at later, Thakkura Peru, another Jaina mathematician. So even in the Jaina tradition, these magic squares were very, very important. A very detailed, in-depth presentation of magic square, as I said, is present in Narayana Pandita's Ganita Kaumudi. We are going to learn verses from Narayana Pandita, and we are going to learn how to build some magic squares. First, Narayana Pandita gives a certain taxonomy for magic squares. What is the current taxonomy for magic squares? We should know. That is also something we should know. Okay. Today, magic squares are called magic, simply magic. Okay. This is a good case scenario. For this itself, there are various contests right now given to build various magic squares. Magic squares, then there are something called semi-magic, and then there is the pan-diagonal. Pan-diagonal is the of the higher order, tougher to build such magic squares. Narayana Pandita will tell you a method, an algorithm in which you can create an exhaustive list of 324 different magic squares. Very, very interesting concepts he gives. So this pan-diagonal magic square has been least well studied unless and until the 20th century started in 1906, 1908. That's when many people started studying the pan-diagonal magic squares in great depth and understanding their properties very well. In 1942, some properties all came out well of the pan-diagonal magic squares, where certain Indians also published how their grandfathers, how one street vendor taught someone. Like that, also some publications have come in Indian Antiquity, a very famous journal called Indian Antiquity. Like this is the modern taxonomy. Similarly, here to construct algorithms efficiently, Narayana Pandita is creating another model of classifying magic squares based on their order. What is the order? What is meant by the order of a magic square, if anyone has been following keenly? Good morning, everyone. What is meant by the order of a magic square?
The number of, like the first example you gave was three columns, 3 rows.
Yes. So the number of rows or the columns, right? Because it's a square, it will be equal. The number of rows and columns are equal. So either the number of rows or number of columns means the order of a magic square. So he's saying take that order of a magic square and divide it by 4. You can get 3 scenarios, he's saying. 1, if it's divisible by 4, you will get the remainder as 0. Number 2, when it's not divisible by 4, then you get 2 other domains. 1, it can be an odd number which is not divisible by 4, or it can be an even number which is not divisible by 4, basically, right? So when you divide any number by 4, the only reminders you can get are 0, 1, 2, and 3. In the case that it is divisible, you divide it by 4 and you get the remainder as 0, such a magic square is called samagarbha. Such a magic square is called samagarbha, which is 4 cross 4, 8 cross 8, 12 cross 12, where the order when divided by 4 gives the remainder 0. When the remainder gives 1 or 3, then it's an odd number, right? Only an odd number will give you 1 or 3. Such a magic square, odd magic square, basically, of where the order is an odd number, that is called a Vishama. Then there is something called the Vishama Garbha, which are even numbers which are not divisible by 4, which will yield the remainder as 2. For example, 6 when divided by 4 yields the remainder 2. 10 when divided by 4 yields the remainder 2. Like that, 6, 10, all these, right, are all examples of magic squares which are Vishama Garbha. Another translation for this is Samagarbha means evenly even. That is twice you can divide by 2. Vishamagarbha means evenly odd. That number is divisible by 2 only once. For example, 6 when you divide it by 2, you can divide it, you will get 3. After that, it will become an odd number. So that's called evenly odd. Samagarbha is called evenly even. Vishamagarbha is called evenly odd and Vishama is called odd. Samagarbha Vishamagarbhe Vishamancheti Tridha Bhaved Bhadram Bhadranke Chaturapte Niragrake Tadbhavetcha Samagarbham Vyagre tu Vishamagarbham Triyekagre Kevalam Vishamam. 3 Eka Agra. Agra means remainder in mathematics. Bhadra Anka, if we take the order of the magic square, Chaturapte, when you divide it by 4, Niragrake, no Agra, there is no Agra, there is no remainder. In that case, Tat Bhavet Cha Samagarbham, that is called a Samagarbha. Dvegre, Dvi Agre, if it is there, it's called Dvegre. In the case of 2 being the remainder, indeed it is a Vishama Garbham. Trekagre, 3 or Eka. 3 va, Ekam va. If that is the remainder, Agram tu. So Trekagre, Kevalam, it's only called a Vishamam without the word Garbham behind it. So that is what he is classifying. Why is he classifying this? He's going to give umpteen algorithms. When it comes to Samagarbha, how to build them, Vishamagarbha, how to build them, Vishama, how to build them, he's going to give us many examples, right? So Vishama are of the orders 3 cross 3, 5 cross 5, 7 cross 7, etc. Samagarbha are of the orders 4 cross 4, 8 cross 8, 16 cross 16, 12 cross 12, etc. Vishamagarbha is of the order 6 cross 6, 10 cross 10, 14 cross 14, etc. Now, do all of you remember the Khatapayadi number system? Is that an easy thing to remember? So we will learn today 2 things. One from Nagarjuna, one from Narayana Pandita. From Nagarjuna, way back in 100 BCE, we see a beautiful mnemonic given by him in the Khatapayadi number system to start building magic squares. Okay. It goes like this. Arka Indu Nidhanari, Arka Indu Nidhanari, Tena Lagna Vinasanam, Tena Lagna Vinasanam. It goes like that. It doesn't mean anything specifically. Right? But Arka is Surya, Indu is Chandra. It's easy to remember. Arka Indu Nidhanari, Tena Lagna Vinasanam, he says. Now, do you remember the Khatapayadi number system? We saw this Khatapayadi number system. Now, help me decode this verse in Khatapayadi number system, please. A stands for
0.
0. Thank you, Darshanji. Ir stands for
Ra is 2.
But we saw in the Khatapayadi number system that ir, that is consonants without a vowel, nachachintyo halaswaraha. Do not consider that into calculation. So ir must not be considered. Ka must be considered. Ka stands for 1. E
0.
0. In again not to be considered. Do
The is 8, not to be considered.
but do is there, no? Id plus u.
The is 8.
The is 8. In is not to be considered. The is to be considered 8. Ni. Na for 0 again. The is for 9 now. Again na. Na is again 0. So 0. And ra for 2.
2.
Te
6. 6.
6. Na
0.
0. La
3.
3.
3. Ig not to be considered.
Da 3.
Na ig not to be considered because ig does not have a swara attached to it. Ig not to be considered. Na is again 0.
Na is 0. Yeah.
B
4.
4.
But Ka should be 3, na?
Gee, that's the rule. Should we go back to that slide? See, you please go back and watch that slide for Khatapayadi number system where we have said that all consonants without a vowel attached to them are not to be considered for calculations. In Lagna, ig is a ig shabda without any consonant attached to it. Is that okay, Ji?
Okay.
Understood?
Okay.
Na again is 0. V is 4. Na is again 0. Sa stands for
7.
7. Na again is 0. Im does not have any vowel attached to it, so it should not be considered. So there are totally 16 digits here. If you put these 16 digits as 444 underneath each other, you will get a grid like this. 0108, 0902, 6030, 4070. So this is like a matrix. Okay. matrix where there is 0, there is no element, which we are going to fill now shortly. This is what we today we call it as a sparse matrix, right? So this is a matrix. So this matrix, we are going to turn the zeros into something. So he is giving us a template, like a stencil, for us to quickly build magic squares. Who? Nagarjuna. Where? Way back in 100 BCE. Right? He gives us this kind of a stencil. What is he saying? There is something called, okay, diagonally across cell. Okay, diagonally across cell. For one, diagonally across cell would be diagonally you leave one unit and then come here. Diagonally skip one place and then come here. For 8, if you diagonally skip one place and come here, you will land here. For 9, diagonally across cell would be here. Is this clear for all? Okay. Now what we need to do is, in the diagonally across cell, for 1, the diagonally across cell is this. We are going to make that as n minus 1. 0, we are going to turn it into n minus 1. Similarly, for 2, the diagonally across cell is this one. We are going to make it n minus 2. Then for 3, the diagonally across cell is here. That we are going to make it as n minus 3.
Why?
Now for 4, the diagonally across is, so we do n minus 4.
Sometimes we are
This is
going.
the technique that Nagarjuna is saying.
Question.
Practically, you can see if you are going out, you don't go in that direction. In practically, there will be only one cell available diagonally across for every cell in a 4x4 grid. Yes, Deepti ji.
Sometimes you are going up and left, and sometimes you're going down and right.
Because we have to find the diagonally across cell. Let us take one by one case. Now, for example, let's take 9. If I go here, will I get my diagonally across cell? Will I
No.
get it, G? No.
No, no,
If I go here, will I get it?
no,
No. If I go here, will I get it? No.
no, no.
For every cell, there will be only one way in which you can get the diagonally across cell.
Mm.
So here only you will get it.
Meaning n minus 3 and 3, you took in all the upper numbers were bigger, lower numbers were smaller. So I thought 3 should be where n minus 3 is, and n minus 3 should be where 3 is.
No. So this 0. So from 3, we are going to go cell across. In all 4 directions, we can diagonally go, but only in this direction will we get the diagonally across cell. Okay.
Why not start from that first column, first row?
Sorry, Ji. Can you say which column, which row?
Why not start from the 0? Why start from the...
No. See, we are following what Nagarjuna is saying, not our own idea of what it is. So Nagarjuna is saying first form this and then start with each number. For 1, go Koshtantara cell. Koshta Antara, means the cell with by leaving one in between. Go across diagonally. From 1, there is only one direction in which you can reach a cell when you go across diagonally and then jump. That cell, turn it into n minus 1. He's saying. This came first. We build this using Arka Indu Nidanari. Using this, we are going to build this. Yes, Deepti ji.
So you're saying do not start from first column, first row. Start from first column, first row, second column. That's where you
No,
start from.
I'm saying we can start from anywhere, but where digits are, not where 0 is. Because 0, we are going to replace it with some other expression.
Okay.
Anywhere, any of the numbers which are non-zero numbers, you can start from. To start from 2, you just have to fill these zeros up with a different expression. That is the objective here. Let me finish it once fully. Then we will again iterate back and try to understand this. So in this is called a sparse matrix today, where a lot of zeros are. I'm going to fill up the zeros with some expression as per Nagarjuna's prescription, where start with numbers which are non-zero numbers. We have only 8 such non-zero numbers, and we have 8 zeros which are to be filled. What Nagarjuna tells us in 100 BCE is go diagonally across a cell and do n minus 1. Just write n minus 1 there. Okay, this is the expression he says. Across 1, n minus 1. Across 3, n minus 3. Across 2, n minus 2. Across 6, n minus 6. Across 4, n minus 4. Across 8, n minus 8. Similarly, diagonally across 9, n minus 9. Diagonally across 7, n minus 7. So where all we had zeros, we have replaced them with an expression called n minus x. And what is that x? X is that number which is diagonally across one cell. So like that we have filled, we have turned this into this kind of a magic square. Now I can plug in any n I want to in this square. I can plug in any n I want to, and I will get a magic sum. I will get a magic square. Shall we try doing that? Give me some n. It can be positive, negative, anything. You don't have to worry about it. Fraction, anything. Okay. Okay. Give me some arbitrary n, please.
8.
8. Okay. So we are going to fill this entire magic square now. So n, we are taking n as the value 8. And Nagarjuna is saying this kind of an arrangement will give the magic sum to be 2n, which means 2 8s are, we'll get a magic sum of 16 now in this cell that we are going to construct now. One, two, three. Now, instead of n minus 3, we are going to do 8 minus 3. 8 minus 3 is 5. 1 is 1. Then n minus 6 now becomes 8 minus 6, 2. Then this is 8 as it is. This is n minus 7, which is 1. This is 9 as it is. N minus 4 is 4. 2 is 2 as it is. 6 is 6 as it is. N minus 8 is 0. 3 is 3. N minus 1 is 7. This is 4. N minus 2 is 6. 7. And minus 1. Okay. 5 plus 1, 6. 6 plus 6, 12. 12 plus 4, 16. 1 plus 9, 10. 10 plus 0, 10. 10 plus 6, 16. 2 plus 4, 6. 6 plus 3, 9. 9 plus 7, 16. 8 plus 2, 10. 10 plus 7, 17. 17 minus 1, 16. 4 plus 6, 10. 10 plus 7, 17. 17 minus 1, 16. 6037 will be 16. 1942 is 16. 5128 is 16. Now let's look at the diagonal. 5, 9. 5 plus 9, 14. 14 plus 3, 17. 17 minus 1, 16. 4 plus 0, 4 plus 4, 8. 8 plus 8, 16. So all the rows, columns, diagonals, all that will add to, this is not pan diagonal. This is the magic sum, right? This is the magic square. I said there are 3 kinds in the modern classification. Semi-magic, where only columns and rows are add up to the magic sum. Then there is the proper magic square, which is the column, rows, and the 2 diagonals add up to the magic sum. Then there is pan diagonal today. That also Narayana Pandita has done, that we may not have the time or scope within this class to cover it. But this is a kind of a beautiful arrangement that Nagarjuna has given. Right? So this is a template, pre-made template. In such a template, you will always get your magic sum as an even sum. Okay. your magic sum as an even sum. That's what you would get in such a template, right? Now you might, let's say, today's date is 10, or give me the birth year that you were born. Someone, any of you.
1979.
79. So 79 is an odd number. So we'll use the next template for the odd number. For odd number, we have to slightly be careful. Earlier, 6 across, we did 6 across, we did n minus 1 across n minus 1, 2 across n minus 2, 3 across n minus 3, 4 across n minus 4. There is no 5 in this square. 6 across, we did n minus 6, right? In 6 across. Here, 1 across n minus 1, 2 across n minus 2, to the same Arka Indu Nidhanari Tena Lagna Vinasanam. Now to get a odd magic sum, which was 79 was your birth year, which we are going to try and get a magic sum for that. So odd number if we need, n minus 1 will be 1, n, for 2 across it will be n minus 2, for 3 across it will be n minus 3, for 4 diagonally across n minus 4. For 5, there is no 5 here, there is next number is 6. Earlier we did 6 across n minus 6, now we are going to do 6 across as n minus 5. Then 7 across as n minus 6, 1 digit lower. Then 8 across as n minus 7, and 9 across as n minus 8. Last time we just did 9 across as n minus 9. So when you do this, you will get the magic sum to be an odd number now. So let's say you desire to build a magic square with the YY, with the digits that is ending in your birth year, let us say 79, you want the magic sum to be, right? So you can plug this in quickly and then get a magic square where the magic sum is your birth year. You can do this for your birth month, birth date, and so on. So now our sum total 2n plus 1 is our desired sum. I've just inverted the problem. Earlier we plugged in an arbitrary n. Now we want to desire, we have a desire that this magic square should have the sum as 79. So 2n plus 1 is 79, means 2n is equal to 78, correct? And n thereby is equal to
39.
39. So now if you plug n as 39, 39 minus 3 is 36. Then 1, 39 minus 5 is 34. Then 8 as it is 8. N minus 6, 39 minus 6, 33. 9 and this is 35. Then we have got 2. Then 6, 32, 39 minus 2. So 3 and 39 minus 1 is 38. Now 4, 37, 7 and 31. Now 33 plus 36 is 69. 69 plus 6 plus 4 will be 79. 1 plus 9, 10, 10 plus 32, 42, 42 plus 37, 79. Like that it goes on. So this will be a magic square where the desired magic sum is achieved. Similarly, let's say your birth year was 88 and you want a magic sum of 88, let us say. So you give 2n is equal to 88, then n will be 44. And then you plug that in into this and you will immediately be able to construct a magic square. We were greatly exploring the possibilities of the sequences, how to balance them off, and very important such, play of numbers. You've got to be really good with numbers. We're talking about 100 BC, right? Where we are doing all this. Right? A lot of play with numbers, a lot of joy and puzzles are all part of the Indian tradition. So here are some more examples. right? So if I want a magic sum as 56, then I choose the even template. If I want odd magic sum, I choose the odd template. Here 56 is an even number, so n will be 28. If I plug that in, I'll get a magic square. Similarly, if I desire an odd magic sum, let us say 67, then I say the equation is 2n plus 1 is equal to 67, thereby n will become 33. If you plug that in, you will get something for 67. This is the Nagarjuna's technique for a 4x4 Samagarbha. I had some more to do. One more. Do you all have a stomach for one more nice technique by Narayana Pandita?
Can I ask you one question going back?
Please, please.
Can you go back to the slide? I think looks like the other numbers were constant, like any like 1, 9, 8, like, and you're stating some
Yeah. It all comes from this, right, Ji? The template is already in place.
so this template will work only because of this encoding.
Of course. Yeah.
So if you want to create some arbitrary number, then
Yeah. We'll teach. All that is there. We're starting with something simple where
something
when you start, when you start baking, right? You want to work with a pre-made cake mix. If I ask you to make the dough from the, so we are going to see all that.
Okay.
Yes.
No, makes sense. Yeah, thanks.
So these are for children, right? Instead of teaching algebra, with equations, you start working with numbers where they plug in, they've got to substitute, they've got to do this, right? It's a very, very fun way. Once I start Bija Ganita for children, I go to this technique of, Nagarjuna, and then I teach them. So this is again good algorithmic thinking for children. We are going to learn for Vishama magic square. Okay, I'll give you resources to learn all kinds because next class we have presentation. So I will give you many resources for our teams to learn. We'll have a brief about it towards the end. So now I'm going to slightly bend your mind, slightly be with me. Okay, and we are going to build some 3x3 magic squares. Children love this. Children, once I teach this, children start doing 121x121 magic square. Somebody did. In one among our Gurukulas, the big chart is also there. So you can do it for any odd cross odd, magic sum. And we're going to pick the simplest of sequence. Any arithmetic sequence you can fill it up with. We're going to pick the simplest of sequence. And then we are going to understand the technique. Okay. The first thing in the technique we must know is that the 3x3 grid has some specific points from which only we can begin the entire approach to building a odd magic square. This is Narayana's technique. Okay, there are hundreds of techniques. We are going to learn a few at least, right? So there are only 4 spots to start building a magic square, an odd magic square. This is a generic technique, right? It helps you build. So this spot is there. This spot, this, and this. Just a couple of weeks before, I sort of arrived at a new technique to start in these corners because Narayana Siddhi does not start in corners. So hopefully one day there will be Anadi or Guru Priya technique or some technique will be published. So somewhere we are working on the properties and all that. See, I'm not going into the math behind them. We are first just learning to apply them. If I go behind the math, then we've got to look at planar, they're like advanced number theory concepts and, many things like that. Let's not go there. Let's not deviate. Let's come back here. Because what we must know is that to have arrived at these algorithms, they should have had like advanced mathematical thought processes. These are not like, trial and error based algorithms at all. Okay. So now we have got these 4 sthanas from which we can begin. Let's call this the north, call this the east, south, and west. This is a convenient thing that we all know. So once we pick north, our movement can only be northeast going forward or northwest. One among these we should pick. We should not alternate between this. 2 as the blueprint for if you start here, you have only 2 choices as the blueprint. Once you have picked north to be your first cell and northeast to be your direction, this is going to be the signature of your magic square. And you're going to build the rest of it based on this combination only. Similarly, if you have chosen north and northwest as the next move, first move northwest, next move as first move as north and next move as northwest, then you should pick this combo for throughout the magic square. Just keep that alone in mind. I will explain what it means in a moment. Similarly, east, I should go diagonally outside. Either northeast or southeast are my only options. When I put my first number in the east cell, my next number I have only two options, either this or that. Once I have picked an option, stick to it. That's going to be the blueprint of your rest of your magic square. This is the foundation. He tells us billion verses to say all this. If we have to go through verses, we have to read some 16 verses today. We'll lose time. So I'm just going into the technique. Second, as I said, you must diagonally keep filling. You pick one direction and stick to that direction. When we go outside a cell, we should wrap around the cell. This we must be clear about. What is wrapping around? I have a bottle here. This is the rectangle, right? Maybe I should stop sharing. You can see my bottle here, right? It has wrapped around. If I had drawn grids on this, right? If it was only a rectangle, correct? And if I wrap around that rectangle, it will come to some point, correct? Might be I need a paper to show this to you. One moment, please bear with me. You see, I'm just making, you all know how to make a square, right? From a rectangular paper here, just doing that. And in this square sheet now, I'm making a 3 cross 3. The visualization power lies in, I don't know. Can you see this 3 cross 3? Now, if I was in this square, and if I had to diagonally go out, okay, if I wrap around this diagonal, you will see that if I diagonally go out, I'll reach this cell, which will be this corner. If I wrap around diagonally, if I wrap around laterally, I will reach in this cell, right? But if I wrap around diagonally
and up.
Diagonally upwards, yeah, which is now in the northeast direction, right? So when I want to go diagonally up from one, I'll reach this cell. This is called wrapping around. This point will be my cell. So if I now go back to my screens, and then I'll show you with a working example. I've tried my best to animate this. Let us see how it goes. So wrapping around works like this. Then there is a third dimensional wrapping around, right? You can even wrap around this entire cube, this entire thing into this. We have made a tire cube like this so that it becomes easy to figure out when you wrap around here. If you go around from the corner, you will actually reach into this place. If you wrap around like this, okay, that becomes clear once you actually sort of do. What is the shape called? Maybe mathematics lovers here.
Donut.
Donut.
Okay, lot of
Toroid.
mathematics. This is called a torus. So many fourth dimension, all physics are all happening with torus, right? If you don't understand, movement on a torus, you can never teach movement on a wormhole to, children and so on. So, this is kind of, improves your neural plasticity. Okay. we've got to visualize this. Okay, let's say I'm going to pick north. Okay, and then I'm going to fix my direction as northeast, let us say. Okay, one example. We're going to fill numbers 1 to 9 in an arrangement such that it forms a magic square. Okay, so we are going to go in this direction now. If I go in this direction, I've gone out. When I wrap around, I will come here. You can try doing this in a paper. You can wrap it horizontally. You will see that you would have ended up here, which will be the bottommost cell. Right? So if I go out, if this section of the paper had wrapped around, it would have formed, an adjacent thing here, right? If this section would have formed an adjacent thing here, if I had wrapped it around, and hence if I go diagonally, I will reach this spot. So 1, if I wrap around, I'll come here, wrap around 2. Now from 2, I should continue in the same direction. The same direction, if I continue, I'll wrap around, I'll come 3 here. Okay. Now when I want to go to 4, the problem is that I'm blocked. 1 has already been filled. Whenever I am blocked, I should move in the opposite direction. What is meant by opposite direction? Narayana Pandita says, you started with north. The direct opposite direction to that is south. So diagonally keep moving unless you are blocked. When you are blocked, now linearly move instead of diagonally in the opposite direction. The opposite, we started with north as our move. So when we keep moving northwards, northeast, we started moving. But when we get a block northeast, immediately move its opposite direction, which is south. You've got to come here. So when you are blocked here, you put 4 down here. Then once you are not blocked, you keep continuing. 5, 6. Now 7 comes here and wraps around and comes to 4. If you are blocked, put it in the opposite direction, which is the south here. Then once you are not blocked, again resume in the same northeast direction. 8, it wraps around here. Then 9, it wraps around here. Now if you see 8 plus 3, 11 plus 4, 15. 1 plus 5, 6. 6 plus 9, 15. 6 plus 7, 13. 13 plus 2, 15. So 1 to 9, if you sum total, it will be 45. 45 divided by 3, 15 will be your magic sum. Okay. To wrap our heads around again, one more example. Okay. North to northwest now. So if I start 1 here, I pick northwest direction. I should be consistent. But what will be my opposite direction? It will be south because my first move was north. Now I start 1 here. I diagonally go across 2. It wraps around and comes here 2. Then I continue in the northwest direction. 3 must come here. It diagonally wraps around and comes here 3. 3, again northwest direction, I am blocked. So immediately go south direction, put 4. Then put 5 in the same northwest. 6 northwest. 7, I'm blocked in the northwest. So I come down south. So 7 I put there. Continue northwest. It wraps around, comes here 8. Continue northwest. Comes to 9 here. Again 6 plus 7. 13, 13 plus 2, 15. 1 plus 5, 6, 6 plus 9, 15. 8 plus 3, 11, 11 plus 4, 15. Now, let's say I start in east and I have 2 directions to choose from. I can choose either northeast or southeast. Once you have picked northeast, I'm going to stay with northeast. Okay. So 1 to 2, east 2 here. 2 to northeast again, 3 comes here. Now, if I go northeast again, I'm blocked. Now remember, we started in east. When we are blocked, we go the opposite direction. Opposite to east is west. So to the west of 3, we should now fill the next number 4. Continue in northeast 5, 6, 7. Again, we are blocked. Continue in the opposite direction to our first move, which was east. Opposite to first move is east is west. So 6. West of 6 is now 7. Continue in northeast 8. 8 comes here. Continue northeast 9. 9 comes here. Again 2 plus 9 11. 11 plus 4 15. 7 plus 5 12. 12 plus 3 15. 6 plus 1 7. 7 plus 8 15. it goes like that. We can try in any of the directions. So if I go northwest, I get this configuration. Northeast, I get this configuration. Then start in east and go northeast, I get this kind of a configuration. Start in east, go southeast, I will get this kind of a configuration. South, southeast, south, southwest. If I go, I'll get, see, 1. From 1, if I go here, 2 will come here. From 2, if I go down here, 3 will come. From 3, if I go, I'm blocked. So I started with south. My opposite direction is north now. So I put north. Again, I continue in southeast. 4, 5, 5, 6. 6, again I'm blocked. So now what I should go? My opposite direction to south is north. Right? See, there is a typo here. After 6, it must be 7. 7, again go down here in the north, in the southeast direction. 8. 8, again southeast direction here. 9 will come here. So this again is 7, typo here.
Yeah.
So you can try these on your own. You can slowly try and see. So this is magic square. This works in 5 cross 5. It works in 11 cross 11. Just have to continue going the direction, and when you're blocked, go the opposite direction. Any doubts here? Okay for all. Let's use this thank you slide. Let's pick up another summation series. Give me another summation series. Let's try doing one more. Give me any arithmetic sequence, please. Anyone, any volunteer. So for example, let's take the 5 table, right? 5, 10, 15, 20, 25, 30, 35, 40 and 45. These are all the 9 digits, right? Now give me one among the 4 directions for me to start from, wherever you would like me to go. Anyone?
Southwest.
Okay, southwest. So we start from south and go southwest. So 5, it starts here. Southwest should go here, correct? So where will the southwest wrap into?
First row, third column.
Will it be first row or third column? If I go this side only, I'll come first row, third column.
Yeah, first row, first column, right?
First row, first column. And that's the visualization thing that we must be. Over time, we'll get good at it. So if you come here, it will wrap around here. If you come here, it will wrap around here. Right? Okay. Now 5 here. So 10 again southwest. It will wrap around and come here. 15. Now if I want to go southwest, in 5 I am blocked. Opposite to south direction is north.
Yeah.
So north of 15, I put 20. Continue in southwest, 25. Then you go 30. Now after this I'll be blocked again, so go north, 35. Now if I go southwest, I'll reach here, 40. If I go southwest, I'll reach 45 here. So 45 plus 25, 70, 70 plus 5, 75. 20 plus 15, 35, 35 plus 40, 75. 10 plus 35, 45, 45 plus 30, 75. Look at the diagonals. 10 plus 25, 35, 35 plus 40, 75. 30 plus 25, 55, 55 plus 20, 75. So all row column diagonals. So we ideally, after multiplication is taught to children, we make them fill, multiplication tables, in magic squares. That's a good abhyasa for that. Good abhyasa for skip counting. And then you can start in arbitrary numbers. You can go to negative numbers. You can do this in fractions. You can do it in any of these methods. A very robust technique that was taught by Narayana Pandita. Any doubts in this for anyone? Any other questions?
So
Yes, Ji?
any exceptions with the rules? Or is it always works all the time?
It works for all odd. This is for where the order of the magic square is an odd number. 5 cross 5, and let's say 1. Okay, very bad drawing. Let's try a 5 cross 5. Oh. Very sorry. Oh, what let's do? Let's go to a. No, let's do it here. So, where would you like me to start?
Let's do,
Northwest.
yeah.
Sorry, Ji. Northwest.
Yeah, northwest.
Okay. So let's go 1 here. So 2 goes here, right? It wraps around, comes here, northwest. Then 3 goes here, again northwest. If I exit here, it will wrap around, come here. 4. Then again northwest, 5 will come here. Okay. Then if I go northwest, I'm blocked. Opposite of north is south. So I pick immediate south 6. Then keep going northwest 7. Then 8. If I go northwest here, I'll wrap around and come here 9. Okay. Then here, if I go northwest, I'll wrap around and come here 10. After 10, if I go northwest, I'm blocked. So I go south 11, then keep going 12, then 13, 14, then 15. Now for 16, if I come around, I'll be blocked. So I put 16 in the bottom. Then if I go northwest, I wrap around and come 17 comes here. Then from here, if I go northwest, 18 comes here. Then 19 and 20. 21 is blocked, so go south. 21, 22. Now go northeast here. 23 comes here. Go northeast, 24 here. Go northwest again, 25 here. So that fills a 5 cross 5 grid. So here 1 plus 7, 8, 8 plus 13, 21, 21 plus 19, 40, 40 plus 25,
65.
65. That will be the magic sum on all rows and columns. Very, very incredible discovery, all these things. No one in the world has done any of these things. The earliest in the West that they know magic squares about is from the Byzantine manual, where you can see some Western art in the 16th century having a 3 cross 3 magic square, 4 cross 4. People will marvel about it. This all went from here to Persia, and there in the Byzantine manual, what was there in the manual was directly copied. Here we have got descriptions and inscriptions since a long time, right? From the BCE, we have had magic squares very clearly. And yantras, many yantras have been done using this. The yantra that I showed you was a Shukra yantra. Then I once went to a Jain college where the principal had a big magic square behind him. And if you are following the Panchangas, Indian Panchangas, especially the Vakya Panchanga and so on, there will be a Rama Bhadra, there will be a Sita Bhadra at the beginning of the Panchanga itself. You will see that, that this is for auspiciousness, that is for this, they would have written. So like this, like alphabets were sacred, numbers too were sacred in the Indian tradition. And an arrangement of them, it creates a certain visual impact for us. It creates a certain impact on the perceiver. So for different magic sums, there is the Shiva Tantra Yoga. There is a text which tells you all the benefits of different magic sums. I've come across an Agastya text, which I'm yet to begin to read, again, which has a lot of magic squares in it. So there are a lot of properties to these magic squares. I'm not going into them, especially 4x4 and Pandale, a lot of properties, a lot of theorems and proofs to be said. Why is this working? This is a brilliant thing. Why is the diagonal method working, right? So there are a lot of mathematics behind it, which we may not have the time per se to go into, but take it from me that it is a very deep mathematics. It's not a simple arrangement of numbers. It's a combination of arithmetic series, its properties, utilizing and balancing numbers in a particular way, and allowing for a construction of a distribution in the variance from the mean, in this case median, how much it varies from, equally distributing it across the grid. Very, very incredible. And best part is algorithmically written, recursively written, there is a break function to it. So you just are taught first the algorithm, you start building, and slowly uncover many properties in it, and goes all the way to a PhD program. That's been the power of Indian mathematics. So that concludes what I wanted to share. I see a few hands up, please, one by one.
I was thinking more from a time series perspective. Is there this is only arithmetic series? Log will not be, logarithmic series wouldn't come through. I'm just thinking through that.
So there have been some series like that. In fact, first after this, what they have arrived at is there are certain magic sums which are called Varga Vargam. Varga means a square, squares. So Indian mathematicians have found some arrangements of numbers. If you square the same elements and create a new magic square with all the numbers squared again, this will also be a magic square. This will also be a magic square. Different magic sum, of course, right? Very, very complex. So what is the logic behind them? How to arrive at them is still a mystery. If you go to this very, very famous channel called Numberfield, he just right now announced a bounty for a 3x3 squares magic square. Where the given original is also for bigger numbers, 7x7, 8x8, it's easier to do such a magic square. Slightly easier as in not really easy. It's computationally very complex. But to do a 3x3 and then do a 3x3, which is a magic square. Now they've given a bounty of $10,000 in Numberfield to anyone who can do even a semi-magic square with 3x3, grid, which will be a magic square, and its squares will be a magic square. In the Indian tradition, we are not able to find the manuscripts, but there is a comment that Narayana Pandita has said that you can make magic squares with squares, cubes. He has identified things with where the base square is a linear set of expressions. It's cubes. Why is the logarithmic question coming up is because in many ways it's a geometric distribution, and hence can geometric distributions work in using a sequence? We are still trying to find out. There is a lot of research. It's a nascent area of research still, and its properties are still being found out. You can go to visit Numberfield, a few other channels to understand some of the cutting edge research that's happening in magic squares. Arunji?
Was there any connection between magic squares and Chanda Shastra? Because if you look at modern topology theory, there's also this person called De Bruin, and obviously he came up with sequences, and then he connects it back to toroidal structures. And I'm just wondering, if this was also the case, that this was essentially connected back to Chandra Shastra too, with these magic square representations.
So the De Bruijn cycles are definitely connected to Chanda Shastra themselves. That I think we slightly saw about it. Yamata Rajabana Salagam and the De Bruijn cycle that corresponds to it. But the magic square in itself, direct connection to Chanda Shastra, I do not know or haven't explored about it yet. However, the Chanda Shastra is always connected to all parts of mathematics, because you've got to know whatever you saw here. All this have to be given in songs, as sequences. So they are all written in some chandas and they are all presented, of course. Especially the one that we saw here, right? The Sarvato Bhadra. There is the beautiful verse, Anushtup, with all the in Katapayadi. The same verse is there in Bhuta Sankhya. So you've got to encode this finally in the Chanda Shastra. But the distribution of the numbers and the properties of the magic squares, how do they correspond to Chanda Shastra, I do not know. However, in true light of being an Agastya Bhakta, I must say that I think this is somehow connected to other planes. We do not still understand mathematics, that we do not understand about other planes of existence of this reality. I feel there is some connection there. I think a lot of time and a lot of research might reveal some aspects. Somehow, in texts that Agastya Maharishi is talking about with respect to space travel, he is bringing out these. I do not know where it is or how it is used. The Siddha text, we are just beginning to dive deep into them. A lot of years of tapasya might be needed to figure out where all this is used and why all yantras work. I feel even to a certain extent that our observational sciences as of now, on what we can observe and measure, if it does not improve to further subtleties, we might not be able to do any measurable experiments based on them yet. However, with Shraddha and the Rishi Parampara, I feel there must be more depth to magic squares than joy of mathematics alone. However, to retain this knowledge system in our humanity, it is incumbent upon us to learn some among these, teach it to our children, and preserve it somehow. Like the Vedas, when they submerge and Varaha comes and again re-emerges the Vedas. Like that, I'm sure many of the knowledge systems, as the Yuga Parivartana happens, must come to the fore again. We must be able to understand deeper correlations in them. I'm trying to understand what are some significant uses to magic squares in astronomy, which is a very, very in a very nascent exploration stage right now. Okay. Maybe end it here and discuss about what we are going to do in the next class.
I think there is one more question.
Please.
Anandji?
Dhanyawad, Madhya. Madhya, so you mentioned earlier about tortoise shell, and that one, at least my basic understanding, it is a kind of tessellation, right? Voronoi tessellation is what I'm guessing it is. Is that an area that Bharatiya Ganitam has explored?
No, they've only named this inspired by that Kakshaputa, having seen some geometric cells. See, we belong to a non-linear geometry era, right? We do a lot of curves earlier to find grids. At some point in time, they found this in the nature to be an inspiring thing, and then they started calling another name for Bhadraganita is also Kakshaputa, the grid that is used to form. However, I do not know if there are any. I'm sure nature works on various tessellations, and also there is encoded in it certain sequences, mainly geometric sequences than arithmetic in nature. However, we need to find out more. I'm sure there must be some inspiration for it. For as of now, with the literature I can study, I can only correlate to it to the visual representation of a magic square in what they have said. Mainly in the Jaina tradition, they call it Kachaputa. In the Hindi tradition, they call this Bhadraganita.
So, Madhya, there the tortoise shell, and then the pattern in even I think cheetah skin, even giraffe skin, right? These are all visually to me. I don't know. I'm sure somebody would have done rigorous
they have
things
done
on it. Yeah, it all seems to me like Voronoi tessellation. But okay, thank you, Madhya.
Thank you.
Okay, everyone. Just please pay attention. The Guru Priya Chaitanya ji is going to explain what we might do for the next class, which is the presentation part of this module. We've done this a couple of times with the students forming groups and doing a short 5-minute presentation. So yeah, please go ahead, G.
Now, G, I may seek your help for the formation of the groups, etc.
Yes.
Or how the group might follow. The resource that I want, I feel one among the objectives of learning Bharatiya Ganita must not just be for the joy of learning, but sort of like how people preserve Vedas by simply chanting them. Similarly, simply knowing these techniques leads to a certain degree of preservation of this knowledge system, and it might inspire children a long way over the time to come and understand our continuing identity. In that sense, I want participants here to take a chance to study some content that would help take Bharatiya Ganita to children. So towards that, this link that I've shared right now, this we have done in in collaboration with the Ministry of Education's IKS division, as well as the IIT Madras CIKS Center for Indian Knowledge Systems. We have created a repository of videos for very young learners. Right? I would like you to go through, pick up topics from the Ganita video library here. Right? This is more in addition to what we have already seen. Some of it, we might have, I would have tried to touch base here, but there are quite a few topics here which have not been covered by me. Say computation of cubes, cube roots, more things in Chanda Shastra, more techniques and magic squares here. If you go to part 3 here, right? And if somebody wanted to learn square roots rigorously, you can see many cases of square roots here in this video. And algebraic identities, understanding areas of polygons. This is a beautiful topic. I would encourage someone to take up Ganita 8 here. I would like you to take up this content, do swadhyaya of this content, and try, and make a presentation by yourselves and present, some among these to the classrooms. I would mainly recommend, chapters, video numbers, Ganita 6, 7, 8, 6, 7, 8, 9. We have touched a bit of them. There are a few new concepts. I would, however, welcome you. 9, we might have completed it fully. However, Ganita 10 and 11 have square roots that might interest you very well. And magic squares part 3 is a very complex Turagagati magic square that is also very interesting. And cubes here, cube roots here. And even if you want to do a deep dive into Chanda Shastra again and present more pratyayas, etc., you are welcome. You're welcome to take any of the topics you are comfortable here in these 18 videos. You can pick up in groups. The more you do, the happier the world will be. So you're all welcome to work this week. Do put in a bit of swadhyaya, please. After every class, by now, at least the Katapayadi Bhuta Sankhya we must be very comfortable with, and then so on. I know it's a lot to ask from you. However, it's a Jnana Yajna that we are all doing. And as part of that, offering ourselves to this process and to time makes a lot of sense. And thereby, the sheer intelligence of designing one component of the course where you all, do swadhyaya intensively is, a much appreciable part. I hope this week we all knock our heads together in small groups and try to churn out some more content for ourselves.
Okay, thank you, G. If anyone has any questions, we can address those now. Otherwise, we will follow the same pattern as the last 2 modules presentations, where we'll send a team-wise grouping, and you all can decide. Looks like the videos are no more than 15 or 20 minutes each.
Exactly.
So it should be very easy to kind of consume over the next couple of days and come up with maybe some examples and things like that, and put together like a 5-minute talk. Okay.
Yes.
We're mainly to encourage the student group here to go and review the material and apply it somewhere. Okay. So
Can you share their WhatsApp numbers or email when you send the groups and the topics?
Oh, sure. Yeah. Did we not do that for the last one, Mahodaya?
No, I missed I think the first time I had a bit trouble contacting the right folks.
Okay. Okay. No, we'll make sure that both email and phone numbers are available. Yeah.
Yeah. Thanks.
Okay. In that case, Gurupriya Chaitanya ji will meet. You will be there next week, right? To kind of look at the presentations and okay.
I'm hoping so. I've just come to IIT Bombay to
Uh-huh.
if I'm not visually there, I will at least be on on the
Okay.
audio.
Yeah. We'd like the
PhD requirement, so I've come here, but I'm happy to be there.
yeah. For feedback kind of thing. Yeah. Okay, ji. Then we can wrap up for today.
Yeah.
Om Sarve Bhavantu Sukhinah, Sarve Santu Niramayaah, Sarve Bhadrani Pashyantu, Ma Kaschid Dukkha Bhag Bhavet. Om Shanti Shanti Shanti. Harihi Om Shri Gurubhyo Namaha. Harihi Om. Thank you, everyone. Have a great rest of your weekend. Thanks, Chaitanya ji.
Namaste. Thank you.
Namaste.
धन्यवाद अजय.
धन्यवाद.
धन्यवाद.